Hello students, my name is Alok Sembal, and in today's lecture I am going to discuss about structure-activity relationship of antihyperlipidemic agents. As I discussed earlier, antihyperlipidemic agents are a diverse group of pharmaceuticals that are used in the treatment of high levels of fats such as cholesterol in the blood. The condition of high level of cholesterol is known as hyperlipidemia. These agents are also called as lipid-lowering drugs. So first of all, I will discuss structure-activity relationship of HMG coenzyme reductase inhibitors. Lovastatin is an important drug of this category. It is a fatty acid ester that is mavastatin carrying an additional methyl group on the carbo-bicyclic skeleton. It is used as an anticholesteremic drug. All HMG coenzyme reductase inhibitors contain 3,5-dihydroxy carboxylate group, a bicyclic ring system, and the lactone ring. All three of them are important for the activity of these compounds. 3,5-dihydroxy carboxylate group is essential for the activity. Also, the lactone ring and bicyclic rings as well as ethylenic bridge between them is responsible for the activity of HMG coenzyme reductase inhibitors. This bicyclic ring could be replaced with other lipophilic rings, and the size and shape of these other ring systems are important to the overall activity of the compound. Minor modification of the bicyclic ring and side chain ester of lovastatin results in two new drug candidates, simvastatin and pravastatin. Pravastatin is a ring-open dihydroxy acid with 6-hydroxy group is much more hydrophilic than either lovastatin or simvastatin. Simvastatin is a good medication to lower cholesterol. Pravastatin can also improve cholesterol, but it is not as strong as other statin medications. It does produces fewer side effects, but is safer for your kidneys and liver. The replacement of the bicyclic ring with various substituted aromatic ring system leads to development of fluvastatin, atorvastatin, and sarvastatin. Here you can see the bicyclic ring system is replaced with an aromatic heterocyclic ring system. Distance between this C5 and bicyclic ring system is also important for the activity. Altering this distance between C5 and bicyclic ring system diminishes the activity of statins. Ethyl group provide optimal activity for drugs containing heterocyclic rings like pyrrole in atorvastatin. Substitution of methyl group at R2 position increases the activity of generated compounds. For example, simvastatin contains CH3 group at R2 position, while lovastatin contains H group at the same position. Now, because of this change, simvastatin is more potent than lovastatin. Thank you.